Okay, so we see our little puppy here again, sitting at a position of -3 meters. Now, take a look at the origin. The origin is wiggling right there. So the origin, again, tells you which way is positive. So going to the right is the positive direction, going to the left is the negative direction based on this origin. Now, you see 2 meters, a speedometer and a velocity-o-meter. Now, right now, the dog's at rest. The dog is sitting still, and the speed and the velocity are both 0. So let's say the dog is going to the right, and going to the right, according to our origin, is defined as the positive direction. So take a look. Take a look. Once the dog starts moving, take a look at the speed and velocity. So you can see that the speed and the velocity are both 1 meters per second. And once the dog reaches 4 meters and stops, the speed and velocity are both 0. But take a look what happens when the dog starts, going back to the left. The left is considered the negative direction. The speed is still 1 meters per second, but the velocity is -1 meters per second. So you have to kind of remember speed is simply how fast you're going, but velocity is how fast you're going in a certain direction. So generally, I don't say all the time, but generally going to the left is considered negative. Going to the right is considered positive. But here's the thing about physics. We can define the positive direction any way we want. But for now, we're just going to keep the positive direction as the right, going to the right. Okay, here's another thing about speed versus velocity. Let's take a look at the world map. Now, let's say you want to take a trip from Boston to China. So it's a pretty long trip. So let's just say it's 10,000 miles. And then you come home, and that's another 10,000 miles. It's a pretty big trip. So you go 10,000 miles there, 10,000 miles back. So the total trip is pretty long. It's around 40 hours of flight. And the total distance is 10,000 plus 10,000, that's 20,000 miles. So quite the distance. Now here's the thing about the plane. Planes travel at a fairly constant speed, but not exactly. They may speed up a little or slow down a little, but over the whole trip, it has an average speed. So take a look at the symbol here, that S with a bar over it. That means average speed. So speed is simply distance over time. So total distance is 20,000 miles. The time is 40 hours. So the average speed over the whole trip was simply 500 miles an hour, so which is pretty typical for a plane. They go 500 to 600 miles an hour. So that is the average speed, going there and coming back. So 500 miles an hour. So that's average speed. Now, average velocity can get a little quirky in regards to if you do exactly the same trip. Now, the displacement is how far you are from your starting point. So if you start at Boston, so let's consider Boston your initial starting point, and China, as your destination, but your final destination is still Boston. So your initial destination is Boston, and your final destination is Boston, because eventually you do come home. So let's say the displacement. So since even though you went your distance you went is 20,000 miles, the displacement from Boston to Boston is still 0 miles. So even though you went a tremendous trip for hours and hours, your total displacement is still 0. Take a look at this. So I'm going to put a bar over V to signify average velocity. Now, the equation is different. It is the change in x over time. So your total displacement is 0 because you started in Boston, you did go to China, but you came back and you your final destination is Boston again. So you really don't have any distance from your original starting point. So it's 0. So 0 divided by anything is 0. Your average speed is 500 miles an hour, but your average velocity is 0. So it is kind of odd that you can have an average speed of 500 but an average velocity of 0. So just kind of be careful here. You know, it's very, very easy to use speed and velocity interchangeably. But remember, speed is simply how fast you're going, how fast you are covering a certain amount of distance over time. It could be, you know, miles per hour, meters per second, kilometers an hour, you know. But velocity depends on the change in position, how much you change your position by, aka displacement, divided by time. So they may seem similar and it's really easy to mix them up, but they're not the same. So more on everything, as always, in the next video.